This is Eureka Math. We are in Module 6, Lesson 11, and our objective today is to analyze number patterns created from mixed operations. So let's dig into this for a second here. Okay, so please go to your problem set. Oop, I went too many pages. There we go. Okay, write your name on the top. And let's go through this. Okay, complete the tables for the given rules. Double x, okay? Double x. So that means y equals 2 times x, because we're doubling x to get y. Okay, so that makes 0 times 2 is still 0. Okay, this is multiplication. Remember, multiplication is going to go up like this. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. And so our coordinates are 0, 0, 1, 2, 2, 4, and 3, 6. Okay? Now, double x and then add 1. So here we've got y equals 2 times x plus 1. Okay. Remember when I said that if we put the x right next to 2, that means multiplication? Okay? There's lots of ways to write multiplication. I could go 2 times x. I could go 2 and then a little point times x. That means multiply as well. Or I can just put them right next to each other, and that means multiply. Or I could put one of them inside of parentheses, and that still means multiply. So there's lots of ways to write multiplication. So if you're ever taking a math test or some sort of standardized test and they do it differently than your teacher, all of these mean multiply. Okay. All right, so I'm just writing y equals 2 times x. Y equals 2 times x plus 1. So 0 times 0, 2 is 0, plus 1 is still 1. Okay. 1 times 2 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. 3 times 2 plus 1 is 6, 7. Okay. And then I'm going to write my coordinates inside the parentheses. Don't forget the parentheses. Okay, 1, 3, and 2, 5, and 3, 7. Draw each line on the coordinate plane above. Okay, so we're going to draw each line. First, we'll start by putting in these points. And I'm going to make the first line orange. Okay, line L. It's going to be orange. So 0, 0, 1, 2, 2, 4, 3, 6. Boy, that looks like a multiplication line, doesn't it? Look how it bounces up like that. I could even keep going. I could add a few more. 4, 8, 5, 10. Okay, so we're multiplying by 2. And this line is L. I'm going to change colors. How about this pretty color? And I'm going to call the next one line M. And line M starts at 0, 1, 1, 3, 2, 5, 3, 7. Oh my goodness, are you noticing here something? This is the first time this has happened for us. I could keep going. 4, 8, wait a minute, 4, 9. We have created a parallel line. But you're saying to me, Miss Luer, you just told us yesterday that multiplication creates angled lines and that addition creates parallel lines. But look what we have here. We have addition on the end, okay? So we've created this line and this line are identical. We've just added one. So in fact, it's still parallel. Okay, they are parallel lines, okay? Because that addition is still right there. And if we did any line like that, we could go y equals 2x and then add 3, that would still be parallel. y equals 2x minus 3, that would also still be parallel because this is the part that makes them parallel to each other. All right. Based on the patterns you see, predict what the line for the rule double x and then subtract 1 would look like. Oh, well, there we did. I jumped the gun on that one. So y equals 2x plus 1 is parallel to y equals 2x. And then those are the first two lines. Now they're saying, what would happen if you did y equals 2x minus 1? Well, they would still be parallel, okay? And we can even do that. We can draw that line, 2x minus 1. So if we used x is 1, 1 times 2 is 2 minus 1, it would be 1. So 2, 1. Oh, I'm sorry. Did I say that right? I'm going to change colors as well. So let's add a couple. Let's put in a couple coordinates here that we can follow. If I used 1, 1 times 2 is 2 minus 1 would be 1. Okay. Next one. If I use 2, 2 times 2 is 4 minus 1 would be 3. And if I used 3, 3 times 2 is 6 minus 1 is 5. Okay. So because the y is still bigger than the x, it's still going up. And 1, 1 would be here. 2, 3 would be here. 3, 5 is here. And you can see that I'm just going all the way up with this nice little parallel line. And that one we are going to call, well, it didn't give us a number, a letter. We'll just write it there. Okay. Circle the points on the line for the rule that multiply x by 1/3 and then add 1 would contain. Okay, so here's the rule. Multiply x by 1/3 and then add 1. So x, wait a minute. Remember multiplication, I can write just like this, 1/3 times x plus 1 equals y, if that's the rule. So let's see. If x was 0, 0 times 1/3 would be 0 plus 1. So this one's not going to work, is it? If x was 2, 2 times 1/3 would be 2/3 plus 1 would be 1 2/3. Okay, that one would work. Let's try it again. 2 times 1/3 would be 2/3. 1 2/3. Good. Okay, let's try 1 1/2. 1 1/2 times, so x, if the x equals 1 1/2, would be 1 1/2, 1 and 1 1/2 times 1/3. So that would be 2 3/2 times 1/3 would be 3 6s, which equals 1/2. And then here would be 1/2. Plus 1 would be 1 and 1/2. Okay, so 1/2 and 1/2, that works. Now, the next one, 2 1/4, I don't think that one's going to work. I can tell already. And you should be able to tell already as well. So let's try it. 1/3 times 2 1/4 plus 1. So that's what we're doing to try and find this answer. Let's see, let's change that to 9/4 just to make it a little simpler. And that is going to be 9/12 plus 1, which equals 3/4, so 1 3/4. Did we get 1 3/4 for our second answer? No, we didn't, so that one doesn't work either. Explain how you know. Okay, well, we created a rule. And tested the coordinates. I'm getting messy today, I apologize. I'm not super neat. Give 2 other points that fall in this line. Okay, well, we know the rule, so we just can plug in any number we want as x, and we'll come out with y. So let's try 3. 3 times 1/3 would be 1. Okay. 1 plus 1 is 2. Look at that. That's a nice one. Let's give another point. Let's try if x were 4. Oh, yes, x are 4. 4 times 1/3 would be 4/3, so that's 1 and 1/3. Plus 1 would be 2 and 1/3. And those would all be on the same line. Okay, so once we create a rule, we just plug numbers into it, and that'll give you the y coordinate. Okay, number 3, complete the table for the given rules. Okay, half of x, that means y equals x divided by 2, okay? And let's see. So if 0 divided by 2, well, what's 0 divided by 2? It's still 0, isn't it? Okay. 2 goes into 0 times, yeah, 0, 0. 1 divided by 2, well, that's a half. So that would be 1 and a half. 2 divided by 2, that's 1. So 2, 1. And 3 divided by 2 would be 1 and a half, right? See, all these skills that we've been learning all year, multiplying and dividing and adding and subtracting fractions, do you see how they've all been building up to help you learn how to use these coordinate planes? And this is just the next step before learning algebra. I mean, this is, and then calculus and all those cool stuff. That's cool stuff. And then you all are going to be engineers and you're going to make lots of money. And then you're going to say, Miss Luer, I'm a millionaire now. Would you like me to buy you a house? And I'll say, yes, please. Okay, next one. Half of x and then add 1 and a half. So that addition is going to give us a parallel line, isn't it? Y equals x divided by 2 plus 1 and 1/2. So there we go. That we already know. We're going to add and subtract anything to our original line. It's going to give us a parallel line. These two are going to be parallel. So let's plug in our numbers. 0 divided by 2 is 0, plus 1 and 1/2 is 1 and 1/2 here. So our coordinates are 0 and 1 and 1/2. Next one. 1 divided by 2 is a half, plus 1 and a half is 2. That was nice, easy coordinates. 2 divided by 2 is 1. So 1 plus 1 and 1/2 is 2 and a half. Are you seeing the pattern? Right? Next. Is that right? 2 is 1. Yes. Okay. And next is 3 and a half. So that's 1 and a half. 1 and a half plus 1 and a half is 3. 3 halves plus 1 and a half is, yes, 3. Okay. So 2 and 1/2, and then 3 and 3. And if we did everything correctly, and I doubt myself a lot, so if we did everything correctly, we should have a nice set of parallel lines. So let's check our work. Let's see, line L, I'm going to make this light blue color. 0, 0, 1 and a half, 2 and 1. 3 and 1 and a half. Okay, so there's that line. And we're calling that one L. And then this one I'm going to make let's go pink. Why not? We never go with pink. Line M, 0 and 1 and a half is here. 1 and 2 is here. 2 and 2 and a half is here. And 3 and 3 is there. So I could keep going with that pattern. And look at that. Parallel lines. That one's called M. Oh my goodness, I lost my line. The faster I go, the straighter it gets. We decided that in class today, didn't we? Okay. Draw each line in the coordinate plane above. Good. Compare and contrast these lines. They are parallel. Good. Based on the patterns you see, predict what the lines for the rule half x and then subtract 1 would look like. So this line here is y equals, this is y equals x divided by 2. Then I think, and this is y equals x divided by 2 plus 1.5. And I can see there, I'm going to switch to black for a second, that this is actually 1.5 between these lines, right? So that distance is 1.5. So if we're going to subtract from that, I am willing to bet large amounts of money. Also because I'm the teacher and I know everything. That's not true either. That this is going to be below that, right? So y equals x divided by 2, subtracting 1 is going to get us below that original line. It's going to be below this original line. So we can pop in a couple if you want. Let's see, if we put in 2 divided by 2 is 1, 1 minus 1 is 0, so 2, 0, that's going to go right here. 3 halves minus 1 would be 1/2, so 3.5. And then 4 halves would be 2, 2 minus 1 is 1. Okay, are you seeing exactly what happened? We predicted it and it came true. Parallel line. Okay, and the distance here then, in between here, that's that 1 that we subtracted, right? Okay. All right. Circle the points that the line for the rule. Multiply x by 2/3. So y equals 2/3 times x minus 1. Okay. So we're just going to plug in some numbers here. 2/3 times 1 1/3. I'm doing this one. Minus 1 equals what? So I'm going to erase this. I'm going to make this 4/3. Which equals 8/9 minus 1. Does that even work? Because this is smaller than a whole number, isn't it? This is going to give us a negative number. Now we're not doing negative numbers because in 5th grade we don't do negative numbers yet, so this one is not going to work. I can tell already. I don't even have to go any further than that. Okay? It's not going to give us 1/9, that's for sure. It would give us a negative something. All right, next one. I'm going to erase this and try again. Okay, so everything stays the same except for the x, which in this case is 2. So 2/3 times 2 would be 4/3. 4/3 minus 1 would be 1/3. Yes, that one works. Okay, let's erase this one again. And we're going to put 1 and 2/3. So in fact, I'm going to make that 3 halves. So I'm going to make that 5 halves. So that would give us 10, 6 minus 1. Which would be 6, 6, right? 1. Which would give us 4, 6, which equals 2/3. Is the y 2/3 there? Nope, it isn't. All right, and the last one, 3, 1. Let's see, so if I put 3 in this problem, 3 times 2/3 would be 6/3, which equals 2. 2 minus 1 is 1. Does work. Okay, we tested each set of coordinates with the rule. Okay, give 2 other points that fall on this line. Okay, well, let's give 2 other points that would fall on that line. If we tried with the number 4, okay, 4 times 2/3 would be 8/3. 8/3 minus 1 would be, well, that would be 3/3, right? So that would be 5. 5/3, which equals 1 2/3. Okay. So if x was 4, y would be 1 2/3, and that would be on the same line. My hand is getting tired. Next one. You want to try a whole number, a fraction? Let's try 1/3. That would be 2/3. Nope, that's going to give us a negative number. Sorry. How about just 1? Nope, still a negative number. Shoot. How about, let's see, we did 2, we did 3. Let's do 2/3. Okay? So if x is 2/3, that would be 4. Shoot. Try not to give you a negative number because I don't want to confuse anybody. So let's try a different one. That's not going to work either. We'll just go whole numbers. Nice big fat numbers. 6. 6. 6 times 2/3 would be 12/3. 12 divided by 3 is 4. Minus 1 equals 3. Okay. Big fat numbers. Nice. All right, then your exit ticket is here. You're going to draw a line L, and you're going to draw a line M, and you're going to compare those 2 lines, and then you're going to circle on the points that anything would be in that line. Then come back and do your homework, please. Lesson 11. Great job. Also, the mid-module assessment is coming up, okay? We have lesson 11 today, and then lesson 12, and then a review, and then it's the mid-module review, so be ready.